Hello everyone, myself Gaganpreet Singh and today I'm going to represent my CWS project on finding row echelon form of a matrix using C++. Now, there are three steps in which we are going to solve this problem. In first step, we define a problem to solve, which in our case is to find the row echelon form of a matrix using C++. In next step, we design a solution, and the last step, we write a program that implements the solution. Now, for any person with a non-mathematical background, we need to explain what a matrix is. A matrix is simply a rectangular arrangement of numbers, symbols, or expressions in the rows and columns, usually enclosed in brackets. I have given an example here, but there is also indexing to all the elements of matrix, which I'm going to explain here. Let's say I take a matrix, say A equal, then its very first entry here is called A11. Then this next entry is called A12. Then other next is A13 up to the point of A1C. Also, and we can go down here like A21, A31 up to the point of AR1. In our matrix here, R is called the number of rows in our matrix and C is called the number of columns in our matrix, and we write our matrix as A R cross C, where R represents the number of rows in our matrix, C represents the number of columns of matrix. Also, there is an indexing to all its elements. Like here we can see here A21, and we can see that it lies in the second row and first column. And also here A12, here it lies in the first row and the second column. So we can say that any matrix element with the indexing as Aij means that it lies at the intersection of ith row and jth column. So this is about the indexing of all the matrix elements. Now the next question is, what is the row echelon form of a matrix? A matrix is said to be in a row echelon form if it satisfies condition given below. All zero rows, if any, must be at bottom. Example I have given here, row like 0, 0, 0 must come at last. The first non-zero entry in each row, which is also called the leading entry or pivot, is to the right of the leading entry in the row above. And the last point, below each pivot, all entries are zero. Like I have given an example here, but I'm also going to explain here. Let's say I take a matrix. Say I take this first element as 0 and here 0. Then all the entries below here must be 0, 0. And here let's say this is the first non-zero entry 1. Then below this one, all entries must be 0. And on the right hand side of the one in row 1, we have no concern. Here can be any entry, maybe 0, maybe a non-zero digit, maybe a negative number, anything. We don't have any concern. Now the next point is to make sure that the first non-zero entry of row 2 must be on the right hand side of the first non-zero entry in row 1. So the first non-zero entry of row 2, maybe it can lie here, maybe 1, 9, or it can also be A or even 0, or it can lie here, the first non-zero entry. But then there is also, if here is 0, then all the entries below here must also be 0, and below the state all entries must be 0. And from 8 we can start in the same methodology. Below 8 all entries must be 0, and the first non-zero entry of row 3 must be on the right hand side of this 8. So in simple word, we can say that the first non-zero entry of row R plus 1 must be on the right hand side of the first non-zero entry of row R. In simple word, this is all this given here. I have also given an example here. Row echelon form A is equals to A2 minus 1 3 for this. Now there are certain methods to convert our matrix into row echelon form. Usually we make use of three elementary operation. Row Ri and Rj can be interchanged. Row Ri can be multiplied by a non-zero constant x, and row Ri can be converted into Ri plus x Rj, where x is a non-zero constant. Like here, let's say I take a matrix 1, 1, 1, 2, 2, 2, and 3, 3, 3. So I can use this row operation, say R2 interchanging R3. Then our matrix become 1, 1, 1. Row R2 is changing by R3. It becomes 3, 3, 3. And a row R3 becomes the row 2, 2, 2, 2. It is same as we just swap up both of these rows. Also, we can use another elementary row operation, which is given there, that we can interchange row Ri by Xri, where X is a non-zero constant. Like I can solve here, like let's change row R2 changing into 2 times of R2. So now because we don't use any row operation on R1 or R3, they both are same. 1, 1, 1, 3, 3, and 3. Now we use the elementary option row R2 changing into 2 times of R2. So it becomes 4. 2 times 2 is equal to 4. 4 and 4. Now the third elementary row operation we can use is interchanging Ri by Ri plus Xrj, where X is a non-zero constant. Like we can use here like row R2 changing into R2 minus 2 times of R1. Using that, our matrix becomes, because we don't use any elementary row operation on row 1, it is same. We don't use any elementary row operation on row 3, it is same. And our second row becomes R2 minus 2R1, which is 4 minus 2 is equals to 2. So these are all of the operation we can use on a matrix, and we make use of these all three elementary row operation to finding the row echelon form of a matrix. Like I have given an example here, we start with this matrix. I'm going to show in my given this matrix. Let's say I first use row 2 changing into row 2 minus 2 R1. So it becomes 1, 1, 1, 0, 0, 0, 3, 3, and 3. Now next I use this elementary row operation, row 3 changing into row 3 minus 3 times of R1. So our this matrix becomes 1, 1, 1, 0, 0, 0, 0, 0, and 0. Now we can see here that this matrix is in row echelon form. As we can see that this one is the first non-zero entry of our row 1. Below it all entries are 0, and there is no pivot element in row 2 or row 3, and all the 0 rows, which are actually 0, 0, 0, 0, 0, 0, are at the bottom. So this is how we convert a matrix into row echelon form. This is example also given here. First we see that on the row 1, the first element is 0, and then in row 2 its first element is 2. So first we try to interchange our rows so that the first element of row 1 must be non-zero. So we do that R1 interchanging R3, which becomes this. Then we use R2 changing into R2 minus 2 R1. Then this matrix becomes this. Then we change using elementary option R2 changing into half R2, and then use the elementary operation R3 changing into R3 minus 2 times R2, by which we can see that our matrix becoming row echelon form, because this is the pivot element of our first row 1, and below this all entries are 0. Then in the next row our first pivot element is 1, which is on the right hand side of the first non-zero element of row 1. Also we can see here below it all entries are 0, and then in the third row we also see this, that it is on the right hand side of the row 2. Row 2 non-first non-zero element. Now the thing is, the row echelon form of a matrix is not unique. So I'm going to use an example here. Let's say I choose a matrix 1, 0, 2, minus 2. Now, here I can see that this matrix is in row echelon form, as this is the first non-zero entry of row 1, and below it our entry is 0, and the first non-zero entry of row 2 is on the right hand side of the first non-zero entry of row 1. Now here I can also use the elementary row operation R2 changing into R2 upon minus 4. So our matrix become 1, 2, because we don't use any elementary operation on first row, and then 0 divided by minus 4 is still 0, minus 4 divided by minus 4 is 1. So we can see that both of these matrices are in row echelon form, and they are not equal. So if we derive them from a matrix, which we can easily derive from this matrix 1, 2, and 3, 4. Like when we use this elementary row operation R3, no, R2 changing into R2 minus 3. No, there is a mistake. R2 the changing. It should be 2. 1, 2, 3, 2. Then we use the elementary operation R2 changing into R2 minus 3R1. Then we get this matrix here. And when we use this elementary option R2 changing into R2 then we get this matrix. So both of these matrices are derived from this matrix, but both of these are in row echelon form. So we can easily say that the row echelon form of a matrix is not unique. So because the row echelon form of a matrix is not unique, we generally find the reduced row echelon form of a matrix. A matrix is said to be in a reduced row echelon form if it satisfies conditions given below. First, the matrix must be a row echelon form with each pivot element is equals to 1 and all entries below and above the pivot is equal to 0. Like here we have this matrix. Then we see that in the first row, our first pivot element is 1 and below it all entries are 0. In the second row, our first pivot element is still 1 because we already used this operation R2 changing to R2 upon minus 4 to make it 1. And then we see that above it, there is a non-zero number 2. So we use the elementary row operation R1 changing into R1 minus 2 times of R2. So our matrix become 1, 0, 0, 1. And here we can see that it is in reduced row echelon form as the pivot, all the pivot elements are 1 and below and above all the entries of pivot elements means all the entries below and above the pivot elements are 0. So this is our matrix in reduced row echelon form. Also, I have given an example here. This is a matrix, then we converted it into its row echelon form and then it's reduced row echelon form. This is it. Now, here are some of the main components of our C++ program. Whenever we write a program, at the very start, we include some standard header files or our own written header files if we write any. So in our program of C++, we include a header file iostream, vector, iomanip, and limits. So we are going to see why we include all these header files and what is the use of them. We first include standard header file iostream in our program. Now, why we need iostream in a program? Because we use standard cin to take user input for number of rows and columns of matrix and each element of matrix, and we use standard cout to asking user for inputs and printing the original matrix and its row echelon form, and also its reduced row echelon form. Like I have given an example here. We use cout, enter number of rows, and then all of these things, which I'm going to explain in the later part. And cout here. Now, if we don't use cout, then we can print anything to our terminal. Like we can't ask a user to enter anything. Like here we print that enter number of rows. If we don't cout, we can't give any command to our user to do this. And without cin, we can't take any command from the user itself. Like if we tell user to enter number of rows, then we use cin to get that number from the user. Now, without iostream, we could not interact with the user in the console. That's why we need iostream in our program. Now, the next header file is iomanip. We include standard header file iomanip in a program which help in formatting. Now, the point is why we need iomanip in a program. Actually, the IO manip is not a actually needed thing in a program. Like it don't mean that if we don't include IO manip, then our program won't compile. Our program will still compile, but IO manip help in formatting. Like I have given an example here. We use C out, then set with 8, and then fix, then set a precision 3, and then we print our matrix element. So what are the uses of all of this? We use a set with n, which set the field width to n character for each number. So the matrix columns line up neatly. And then we use set a precision n, which set the number of digits after the decimal point up to n. And we use a fixed, which forces number to be written in fixed point notation, not scientific notation like 1.23 e plus 03. Like when I say 3000, then we normally write it as 3 into 10 raised to the power 3 in scientific notation. When we use fixed, it forces number to be written in fixed point notation like 3000. I have also given an example here. Here 12.34562.1.123.456. Now without a IO manip, all of these things become very kind of irregular and messy because we see that in here 12.3456. Here are 4 digits after the decimal point, and 2 point there is only 1 digit after the decimal point, and 123.4 there are 3 digits after the decimal point. While when we use all of these things, set with 8, fixed, and set precision 3, they all line up neatly, and we can easily read them as a number of digits after the decimal point are constant. So without IOManip, our output will be very hard to read and messy. That's why we include IOManip in our program. The next thing is we include standard header file vector in our program. Then the question is why we need vector in our program? Because we use a vector to vector, which is called 2D vector, to create our matrix, which can be accessed in a vector header file. And we can see here. Now, then the next question is why we need vector? Why can't we use array? So the thing is, for vector, we can choose a size during runtime, but for array, size need to be defined during compile time. So array can work only for one size of matrix m cross n, while we can use vector for any size of matrix. Let's say I choose an array and write that its size is n. Then I can't enter the value of n during the runtime. It's the value of n must be defined during its compile time. So array can work only for one type of matrix. While for vector, we can just write that this is a vector of size n, and then we can enter the value of n during runtime. So we can use vector for any size of matrix according to our need. Now the fourth header file, we include standard header file limits in our program. Then why we need limits in our program? Actually, in our program, we use two functions, dot clear and dot ignore, which are actually part of the IO stream. But to properly use them, we need to use standard numeric standard strings as mass, which is written here, which is actually defined in the limits header file. So I have given also this code output here, double safe double value while true, and then scene dot face scene dot figure. Now what do these functions do? I'm going to explain in the next slides. Now, when the user enters the invalid input, like I ask the user to enter for number of rows, and the user enter something like A. Now, this is not a number, this is a letter. So our standard scene goes into fail state. Now, when our input string goes into fail state, so in at that times the standard scene stream enters a fail state or error state, which prevent further input operation from working. So when user enter a one wrong value during the standard scene when asked for values, all the standard scene stream enters the fail state, which prevents even further input operations from working. So we call standard scene dot clear, which clear those error flags, allowing the stream to be used again. Now then the problem is, if I ask the user to enter just one integer and he enter a b c, then the standard scene dot clear will only enter that wrong value which gets in our stream, which is a, but the bc is still in our stream. So I have explained here, like standard scene dot ignore discards the bad input still left in the buffer, but then the question is how much should we ignore? Like when I give the example that user enter ABC, now A goes into our in C in, and A gets cleared by dot A clear, then BC still stays in the buffer. So standard C in dot discards that bad input. But then the question is how much should it ignore? So as we don't know how many characters the user has input, thus we use standard C in dot ignore standard numeric limits, which actually means that ignore everything up to the maximum possible stream size, effectively clearing the whole input line. The slash n ensures it stop discarding once it reaches the end of the line. And I have given an example here. Suppose program expect integer, but user input ABC 1, 2, 3. Now, without using standard scene dot ignore standard numeric limit, all of this, the leftover BC 1, 2, 3 slash n still stays in the buffer, and the next scene reads it immediately, and the program is behaved. Now, when I use this with numeric limits and all of this, it flushes the whole invalid line, and the program can safely ask again for input. Now, then the question is, what if I use standard string dot ignore 1000 comma slash n? So if user and use this, if we use standard string dot ignore 1000 slash n, then it will work fine if user enter less than 1000 characters. But if user enter more than that, then it will behave as if we don't use it at all. So we do not actually recommend it at all. Now then the user question is, what if I don't include limit setter file in my program? Then we need to go the wrong way as listed above, just believing in God that user enter less than 1000 characters. Now the next thing is, which one should we use to write our program, class or sub function? Now, for a small program, we generally use sub functions, but for big program, we prefer classes over sub function due to the following reason. The data and the functions that operate on data are bundled together. Outside code does not need to know how the matrix is stored internally. They just call methods. So I can explain it like when I create an object in a class, then all the values are already associated with it. I don't need to pass some other values. I just use our object and the function, and all of the work is done. While if I write a sub function, I need to pass all of this. In my program, I write a matrix. Then if I write a sub function, I need to pass the matrix, its number of rows, its number of columns, and all of this data. While if I create a class, then in class, I just use a function on my object and all the work is done. And the second is, when our program is large, it is difficult to read and manage multiple sub functions, while class functions are easy to read and manage. So then the question is, should we never use sub functions to write a program? No, we can use sub functions to write our program and it will also work fine. But for future users and distinction between our program elements as private and public, we prefer classes as they are easy to use and provides about distinction. Then the question is, what is private and public? We are going to see this in the next slides. Now here are components of classes in C++ in our program. There are first topic is access specifier. Now in C++ we actually have three access specifier: public, private, and protected. But in our program we only use two access specifier named private and public. So we don't usually take any concern about protected. We only discuss about both of these things. For our classes in C++, we generally make use of two access specifier named public and private. Now, member functions, members or member functions declared as private are only accessible inside the class by its own methods. Outside can't directly access them. And members declared as public are accessible from anywhere. This is where we define the interface, the function that users of our class can call. Now, what are the benefits of access specifier? Critical data is protected from accidental misuse, and it hides the implementation detail, shows only the user's useful functions. Now, I'm going to show it in the VS Code itself. I here write class matrix and private rows and columns. Then what it does, I create a private and rows and columns. So if I come into my main program, and here is I'm define a matrix M of rows R and column C. Now if I try to do something like M dot rows is equals to 3. I should just for this time I'm going to comment out this all of this. So if I run this program, it is slowly running. then we get an error stating that int matrix row is private within this constant within this context. So we can't provide the values of rows and column directly. We need to provide them by the method we have given here, which is actually constructor function, which we are going to see in the next slides. So this is the use of that we can't access directly these elements. We need to follow a certain procedure in which we have already given all of these error handling like standard C dot clear and ignore, due to which our user can't input any invalid value. Now, then the next part is a constructor function. Now, a constructor is a special function in a class that runs automatically when you create an object. So, normally we don't even need to create our constructor function. It is automatically created. But we normally, when we use something more important things, then we create it. Now, a constructor is a special function in class that runs automatically when you create an object. It has the same name as the class and no return type, and its job is to initialize the object. Now, why we need constructor in our main class? Because we can't directly access the private members of our class. We use constructor function, and we always make our constructor public because we can't directly access the private members. So we make use of constructor to access them. Now here is the constructor in our program. When we use a matrix M R comma C, like I have shown in the here this is matrix M R comma C, the constructor is automatically called, and this R and C, rows R and column C, it stores the number of rows and columns in our matrix. And here we see matrix dot assign R comma vector double C comma 0. Then it creates a 2D vector R cross C of the size R cross C and fill it with all the entries as 0 for first initialization. And so right after object creation, you already have a valid matrix filled with zeros ready to use, like I have shown here. When we first use this standard vector double column 3 comma 0, then it creates a vector like this 0 0 0, and we can also use this. We can see here that it is this create. Now when we use matrix dot assign R comma vector double all of this, then it creates R copies of that row, like if R is equals to and C is equal to 3, it creates our vector like this I have shown here. So we go to again to our slides. Now, this is the most important part of our program, an algorithm. An algorithm is simply a step-by-step procedure to solve a problem. In our program, the main problem is convert any given matrix into a row echelon form. Now, our program follows a specific algorithm, Gaussian elimination method, to convert matrix into row echelon form, and Gauss-Jordan elimination method to convert matrix into its reduced row echelon form. Now, this is the algorithm of Gaussian elimination method, which I'm going to explain from code and the OneNote. So first, in our code, we get to the row echelon here. Now here, lead is a kind of used as a pivot column, and then we use a for loop. For int r is equals to 0, r less than rows, and r plus plus. Now I'm going to explain all of this from OneNote and give an example in the right side. Let's say I take a matrix 0, 0, 0, 0, 1, 2, 3, 4, 5, and 6, 7, 8. So I'm going to use all of this program like here. First, it will say lead is equals to 0. So it works as our pivot column that starts from this column. Now, and we use a for loop. For int r is equals to 0, r must be less than the rows of the matrix, and then r plus plus. And if a lead is greater than or equals to columns, then return. Then simply return from this function. Now then the question is, why don't we use lead equals to columns? Why don't we include it? So this is some indexing problem in our matrix and the vector itself. Now in a matrix, I'm going to I'm going to show here. Like when we define a matrix, I have shown earlier that our indexing start from A11, A12, A13. But when we create a 2D vector, its numbering don't start this way. Its numbering start this way: A00, A01, and it go until the point of A0, number of column -1, and even below here it goes A10, A20, up to the point of A R -1 comma 0. So this is an indexing problem which we face, that vector is defined like this indexing and matrix is defined in that indexing. So here we because we write our program in a 2D vector, so we use the vector indexing part. Now if we let greater than or equals to column, then return, which is actually fully right, that if a lead greater than number of column, then it just goes outside the range of our matrix, so we call it to return. Now first we use int I is equals to r. So and then we use this while loop to find our pivot row. Now I'm going to explain here. Let's say I take my matrix which I have written here and start from this. Now at the very start, first our this let, I'm going to use let as L, and let is first 0, and when the loop first iterate, R is also 0. Uh, Let me first use all of this that we can. So when we use a lead is equals to 0 and R is equals to 0, first it uses I is equals to R. So our I becomes equals to 0 at the very start. Now then our while loop checks if matrix I and lead is equal 0. And so it checks if entry of I, which is 0, and the lead, which is 0, is 0. And we can easily see that this entry is actually 0 here, because this is this entry which is 0. Then while loop say that increase the value of I. So I gets incremented to 1. Then we check the value of 1, 0 in our matrix, which is still 0. As we can see, this is 0 still. Then it says increment the value of I again. Then we get to this 2 and 0, which is still 0. As we can see here that this is still 0. So when it increments the value of I to the 3, then because we see that this is I equals to 0, this is 0th row, this is I is equals to 1, and this is I is equals to 2. But we see that for I is equals to 3, we have no row. So when I becomes equals to 3, which is actually the number of rows. So when I is equals to rows, again put I is equals to R, which is the most important part of our program, because if we don't use this I is equals to R in our program here, then I value will still be set to the previous value, and then we use lead plus plus. So the value of lead simply gets incremented, lead becomes 1, and if we don't use that, I is equals to R in our program, then our I will still be 3, and it will go into the next column in still same way here, and it will find no value here. So lead will still be incremented and still go and still go. So our program simply fails if we don't use that I is equals to R in our program. Then we use I is equals to R, I value is still resetted again to 0. So I is equals to 0, L is equals to 1. We first check the value of 0, 1. That is it 0, which is actually yes. Here we can see this is 0 and 1, 0, it is 0. So it is 1. It says then increment the value of I by 1. So our value gets incremented I is equals to 1. Then we check the element of 1 and 1. which we can see that is not equals to 0. We see that this is 1. So here I is equals to 1, at which this is not equals to 0. So what our while loop then says to do, we see that here it is not 0. So while loop stop iterating, and then we go to the next part where it says that swap the rows. Let's swap the row I by row R. So here we see that our R is currently 0 because the loop is first time iterating. So it says us to do the operation just like as if changing in row R1 by interchanging row R2. I have already explained here how to do this. So it is 0036 0036 0147 0147 and 0258 0258. Now this is until the point we have used in this. Now next thing is to normalize pivot row. Now here our first we need to find div, which is matrix R, and lead. What is the value of our R, which is 0, and what is the value of our lead, which is 1. Now we actually use this to, as when we find the pivot element, we use the swap. So actually this is the value of our pivot element, as 0 and 1 is still 1. And then we said what, that if div is not is equals to 0, which we can already see that it is not is equals to 0, it says us that use this loop matrix R comma J. Here our R is currently 0 and J is currently, wait, J is iterating, and to divide it by this. So it is same as if we use this operation R1 interchanging R1 upon div. It works as the same because when j 0, 1, 2 divided by 1, that it is same as if we use this elementary row operation R1 interchanging R1 upon div, which is currently 1 here, so it don't make any difference. So I'm going to write our matrix again here, 0, 1, 4, 7, 0, 0, 3, 6, and 0, 2, 5, 8. So as I have written here, then because div make nothing at all, then our next thing is to eliminate the entries below pivot. So because k is equals to r plus 1, we are only going to eliminate the entries below the pivot. Here our r is 1. So first our k becomes equal. R is actually 0, r0 by mistake. Then k is at the very first 1. So when k is equals to 1, we are told to find the multi, which is matrix k comma lead. No, k and lead. So what is the value of our multi? It is the value of k and lead, which is actually 0 here. So we don't actually find anything of worth thinking. So we actually iterate this value. I'm going to explain it here because it don't make no sense. Here, what is the value of multi? It is 2 and 1, which we can already see that it is 2. So our value is 2. And then we are told what? That use this for loop and j is equals to 0 to j less than columns and j plus plus, and use this matrix k comma kj. K is 2 here. So 2j, and change it into like 2j minus multi times, which is currently here 2, our r, which is still 0, and j. And we can see here that it is the same operation as using R3 interchanging into R3 minus 2 times of R1. Because we can see here this 2 say that it's in the third row, and j and this j, they means the same column. So it is the same as using the elementary row operation R3 interchanging R3 minus 2 R2. So when also I don't use any operation here, because here it is this R2 interchanging R2 minus 0 times R1. So it makes no sense to explain anything here. Now I'm going to come here at last. Now here 0, 1, 4, 7, 0, 0, 3, 6. And now 0 minus 2 times 0 is still 0. 2 minus 2 times 1 becomes 0. And then the next entry comes here, 5 minus 2 times of 4, which is minus 3, and 8 minus 14, which is minus 6. So we see that here k is iterated over all of the loop, and r is also iterated, because when k value becomes 3, it is not less than a row. So this loop is completed and this loop is also completed. And then we go to the next place here, which is to use lead plus plus. So our value of lead gets again. So L becomes equals to 2. And then we see that this for loop ends here. This is the bracket of the for loop. Now it can be easily seen. So for loop iterates again now. When the for loop iterates again, our value of r becomes now 1. So it will first find what is the value of, we come here, for loop, and this. Then I is equals to r first. I equals to 1 and L is equals to 2. So first the while loop check is the value of this is 0. And we can easily see this is first and this is not 0. We can see that this value is 3. So this value is not 0. So then we go to the swap, which says swap mat I comma mat r, which don't do anything at all, because it is as if using the swap and matrix 2, no 1, and mat 1. So it is the same as if we use this operation R2 interchanging R2, which makes no sense because R2 remains same. So it uses nothing at all. This is our matrix. Then after this swap, what are we going to do? We have already find the pivot row and we have done the swap. Then the next thing is to use this div. Now what is the value of div? Which is R1 and lead 2. And we see that div is equals to 3. So now we are going to use this for matrix r comma j. R is 1 here and this is j, and interchanging all of this into 1 j divided by div, which is as if we are using this operation r2 changing into r2 upon 3. So then our matrix become 0, 1, 4, 7, 0, and 0, and 3 divided by 3 is equals to 1, and 6 divided by 3 is equals to 2, and here is 0, 0, minus 3, and minus 6. So now the next, we have already done the normalization here, normalize pivot row, make it 1. Then the next thing is to make the, using this for loop and for loop, double for loop, eliminate entries below the pivot. Now we are going to use, first we need to find a value of k at the very first. When this for loop iterates for the very first time, the value of r is 1. So k is equals to 2. And then we need to find the value of multi, and we see that at k is equals to 2, and also here k and lead, because as we already seen earlier, here lead is also is equals to 2, and what is the value of this 2, 2, which is minus 3 here, which is minus 3. And then we use this for loop to do this operation, which is same as if we interchanging all of these elements minus 3 times what is the value of r here. We see r is 1, and a j, which works similarly as if we use the elementary row operation r3 interchanging r3. Now minus minus becomes plus 3 times of r2. So what will our matrix become? 0, 1, 4, 7, 0, 0, 1, 2, and here because 0 plus 3 times 0 still 0, 0, and minus 3 plus 3 times 1 is 0, and minus 6 plus 3 times 2 is 0. So in this way our this loop is fully iterated, because when k value increases by 3 it is not less than or equals to rows. So this our loop is completed here. And then we again gets to this place where it says to increase the value of L. So now our value of L becomes 3, and because our loop for loop also iterates, R value also becomes equals to 3. That I have seen here. Wait, sorry, my mistake. R equals to 2. So now when we go to here, then first we use this I equals to R, which is 2, and the while loop will check the value of this 2 and 3, which we can see here that this is 0, 1, and 2, 0, 1, 2, 3. So this is the value which is actually 0. And then when this while loop tries to increases the value of I, then it simply becomes equals to the number of rows. So it says again put I is equals to R, which is simple here, and then use lead plus plus, in which lead becomes equals to column. So this simply return the for this all of the operation is completed, because when it uses I is equals to 3, it sees that I becomes equals to rows. While loop sees this, then it uses again put I is equals to 3 and increase the value of lead, due to which our L becomes equals to 4, which is equal 4, which is also equals to the number of columns. And then simply we have written here return. So Hey, at this place, our fully of the function void to row echelon is completed, and we can see that this matrix is now in row echelon form because here this is the first non-zero entry of row 1, and then the first and below this all the other entries are 0, and the first non-zero entry of row 2 is on the right hand side of the first non-zero entry of row 1, and below its all entries are 0, and the zero row, if any, must lie at the bottom, which you already see here. So this is how we use this method to convert our matrix into row echelon form. Now here is our next function, which is to reduce the row echelon form. Now for this, I'm going to use a normal expression like 1, 2, 3, 4, 5, 6, 7, 8, 9. I believe it is good. So here, now the very first part of this to reduce row echelon is same as the previous one. Until we see here, this whole portion is the same as we studied earlier. So I'm not going to explain it in a much common way. This is pivot column, as I already explained earlier, even though there is no need. So when this iterates first, L is equals to 0 and R is also equals to 0. So L is equal to 0, R is equals to 0. The while loop first check this value, and our I is equals to 0 currently. It checked I and L, which it see that is not equal to 0 because we see this is 1. So it says swap, which is nothing at all. I already explained. It is as a swap row 1 with row 1. So nothing happens here. And then this next thing, the normalized pivot row, which also there is nothing at all because our div is 1. So it uses the same as I have explained earlier, that interchanging row 1 by row 1 upon 1. So our matrix is still the same here. Then we use this next part. And here it is, there is the difference lie that we use this k is equals to 0 to less than the number of rows, and use this function only if k is not is equals to r. This is the most important part which I'm going to explain in this way. Let's start this loop working. First k is equals to 0, and we see that r is also equals to 0. So this time our loop does nothing at all. Now when k becomes equals to 1, the loop iterates and we're going to find the value of multi, which is 1, 0, which we can see that is 2. So now we are going to use the, as I have explained earlier here, because k is 1, 1 comma j is going to be replaced by 1 comma j, this is 1, minus 2 times of r, which is currently 0 comma j, which is same as using r2, interchanging r2 minus 2 times of r1. Now using this expression, our element become, our all of these elements become, matrix becomes 1 4 7, because we don't use any operation on row 1. It becomes 0 plus 2 minus 2 times, and 3 6 9, 3 6 9, and here is 5 minus 2 times 4 is equals to minus 3, and 8 minus 2 times of 7 is equals to minus 6. And this is where the internal loop iterates fully, as we have seen. This internal loop is fully iterated. So then this loop again iterates this for loop. Now the value of k is equals to 2, and our multi, which is 2 0, we see that it is 3. So we use the same as I have explained earlier. We interchange 2j with 2j minus 3 times of rj, which is currently 0 here, which is same as I use this operation r3 interchanging r3 minus 3 times r1. Now when I use this operation, my matrix become 1 4 7 0 minus 3 minus 6 and 0 and 6 minus 12 is equals to minus 6 and 9 minus 21, I think it is minus 12. And we see that at this place both of these loops has completely iterated, because when k becomes equals to 3 it is not less than number of rows, so they both of these loops have fully iterated at this point. So then our next thing is lead plus plus, increase the value of l. Now l becomes equals to 1 and r becomes equals to 1. So and when I equals to 1, we check in the while loop if this value is 0, il, which we can easily see is not equal to 0. So the next thing is to swap, which I have already explained. The swap, which is in the row 1 and the row 1. So it makes no difference at all. And then we go to the next thing, which is to normalize the pivot row. We find the div. Here r is 1 and lead is 1, and we see that it is minus 3. Then we use this loop to create all the values of 1j by 1j upon 3, which is simply, as I explained earlier, is the same as r2 changing into r2 upon 3. So now our entries become 147, no, minus 3, and here also minus 3. So 1 4 7, 0 divided by minus 3 still 0, minus 3 divided by minus 3 1, and minus 6 divided by minus 3 2. This is 0 and minus 6 and minus 12. And then this is our next part, eliminate other rows above and below the pivot. So at first our k is equals to 0. And then we find the multi, which is k and lead, and we see that it is 4. Then we use the same as I have explained earlier, that it works as if we have used this elementary row operation, r1 interchanging r1 minus 4 times of r2. Now I have explained earlier how all of these operations work, so I'm not going to explain it now. Now 1 minus 4 times 0 is still 1. This becomes 0. 4 minus 4 times 1 And 7 minus 4 times 2 is minus 1. And this is 0, 1, 2, 0, minus 6, and minus 12. Then, when our loop iterates again, k becomes equals to 1, at which it becomes equals to r, so it does nothing at all. When k becomes equals to 3, we find duality, which is to 2, 1, which is minus 6. So then our loop iterates, which is the same as using this R3, interchanging R3 minus 6 times of R2. Then our matrix becomes 1, 0, minus 1, 0, 1, 2, and this 0. And this minus 6 becomes 0, and it also is 0. Now, this is our matrix in reduced row echelon form, because when it iterates again, then L is equals to 2, R is equals to 2. I think I have explained here. L is equals to 1, R is equals to 1. Now L is equals to 2, R is equals to 2, at which our I is equals to 2. It checks the value of 2, 2, at which we can see that it is equals to 0. So when we see that this value is still at 0, so when it increases the value of I, while loop increases the value of I, it sees that it becomes equals to number of rows. So then it says that in previous, make the value of I to its previous value and increase the value of lead, at which lead becomes equals to 3, which is equals to number of columns, at which our function returns. And we see that this is our whole of the operation in which our matrix are turned into reduced row echelon form. As we see, this is the first pivot element in row 1, and it is 1, and below its all entries are 0. This is the pivot element of row 2, and above and below its all entries are 0, and the 0 row, if any, must be at the bottom. So this is how our function of to reduce row echelon form works. Also, it is written here like, first, using this lead is equals to 0, we start with the leftmost column. Then we use this for loop to cover all the rows. And if a lead becomes greater than or equals to columns, then return. And also we tries to find the pivot row. Then we use int I is equals to r. Then we use this while loop to find the pivot row. And then if we find that this value is 0, then we say that go lower. And if we see that I becomes equals to rows, then we again uses that I value becomes equals to its very previous value and go into the next column. Now, which I have written here. If lead greater than equals to number of columns row, find a pivot. Look for I greater than or equals to r, where the entry in column lead is non-zero. If no such row exists, increment lead by 1 and repeat step 3. Now, if we find a value in some, like say as I have found here, I can show here. When we start in the previous matrix, is I think here it is. Yes. Now here I equals to 2, then I is equals to 0, then I equal to 1. When it finds our pivot element I is equals to 1, it says swap it. So after swapping it, we convert this into like this. This is what the swap do. Now we need to make the pivot row is equals to 1. Normalize pivot row, we make pivot is equals to 1. Now swap row I with row R, so the pivot is in position, which is this. Now normalizes the pivot row. Now it is not always needed, but in Gaussian elimination method, this is how it is done, so we use it. So normalize pivot row. Now divide the entire row R by its pivot value to make the pivot is equals to 1. Now this is what it is, as I have explained earlier. Now eliminate entries below pivot, which is this. Now as I have explained earlier how the rule of these loops work, both of these loops. For every k greater than r, subtract multiplier into pivot row from row k to make all the entries below pivot is equals to 0. After doing all of this, move to the next column and repeat all of these steps until whole of this for loop will iterate. And as I explained earlier, that the first part of the reduced row echelon form is also the same. So I'm not going to explain it in very detail. Like lead start with column, each row start from top to the bottom. If lead greater than equals to column, then return. If row I greater than equals to where entry in the column lead is not 0. And if none exists, move to the next one, which is this lead plus plus. And swap row I with row R to bring a pivot into position, which is this. Normalize pivot row, which is this. And then this is the difference. Here we use k is equals to 0, so k less than rows. Just to make sure that we don't subtract a row 2 from itself. Just means kind of if k is equals to 1, then it is row 2. And we make sure that it don't subtract itself from itself. So k not is equals to r. This is the difference we make, and all the things are same. Now for every time k not is equals to r, subtract multiplier into pivot row from row k to make column lead is equals to 0 in that row, and then move to the next column using lead plus plus and repeat all of this process until all the rows are processed. Now till now we have covered all the essential materials, so now let's dive into our program. Now this is our program. I'm going to show from the top. First, we include all these standard header files in our program, and using this class we created. First, we make private, which is rows, columns, and our 2D vector. And also we make a safe input, which we use to get our input for any variable, and double value while do all of this. We have also handled any error, like we first double safe input and then we create a value. If while we state this true, that this loop will all the time iterate until we return. So if first we ask the user to enter a value, if user enter a wrong value, which is scene.fail, that if scene goes into fail state, do all of these steps which I have explained, dot clear and dot ignore, and then print that invalid input, please enter a number. So and this loop will iterate again. So we come to here scene. So this is how it works. And if user enters a right value, so we go to this else, which returns a value. Now in public, we have this constructor here, as I have explained earlier already. Now this is how we ask for input. Now void input cout, enter the matrix elements as numbers only. Now for I is equals to 0, I less than rows. Now it is very easy to explain this, and also this thing that I use this here. See, when I is equals to 0, j is equals to 0, it print as if we are asking the value of 1 1. Now this is due to the reason that I have explained earlier, that in 2D vector the indexing starts from 0 0, while in a matrix the indexing starts from 1 1. So we need to make sure that our user is finding the row echelon form of matrix. So we use the indexing of matrix. So that is why we do this plus 1 here, and no other reasons. Now it works as if first when I is equals to 0, I can also show here. When I equals to 0, then it will first j is equals to 0. It will ask the value of 0 0. Then it will ask the value of 0 1. It will ask the value of 0 2. Up to the point it go to the point of 0 c minus 1. And then it will then increase the value in the same way until the go to the point of r minus 1 0. And it will stop iterating once we reach this place. At this place, the whole of the matrix elements we have taken an input. So this is how this input works, and matrix ij is equal to safe input, which is written here as I have shown. It is already understood, so no need to think. Now this is our print value. This is also very easy. Now this is where we make use of set with head fixed set precision. As I have explained that formatting is very needed in this. And we have used this space here so that there will be space between all of our entries. And then first it is the same as I have shown. First I is equals to 0 and j is equals to 0. Its value is printed. Then 0, 1, 0, 2, 0, 3 up to the point of 0 c minus 1. And then after this full of the first row is printed, then we use this slash n which goes into next line. So this is how it was. Then we go into the next line and the value started again 1 0 1 1 1 2 1 3 up to the point of 1 c minus. Now I have explained both of these functions also void to row echelon form and void to reduced row echelon already. So then we go into our main function. We make use of two of these integer values, integer r, integer c. Then we ask the user to enter number of rows. Now here is the interesting thing. Now we use may or. This is or operator. If the user enters something due to which scene goes into fail state, like we ask for r and r as a number and user enters something like a, then this goes into fail state. But we also use this that if a user enter the value of r less than 0, because less than or equals to 0, because we know for a matrix the number of rows must can be 1 2 3, but they can't be 0 or negative because it makes no sense in the language of matrix. So we use that if user enters something like this, that he enters a wrong value or a negative value, then ignore, then first clear, then ignore all of these entries which user and ask the user to enter again valid input, enter a positive integer. And then same for the number of columns. Then use here we call the constructor function to create this matrix, and then we make use of this input which is here void input to ask for all of the values of the matrix, and then we use this m.print to print our matrix. Using this to reduce to row echelon, we print our row echelon form for matrix, and to reduce row echelon, we enter the reduce row echelon form for matrix. Now here is a kind of problem in our program that first here after using this to row echelon, our matrix is already in a row echelon form when we call this function to reduce row echelon on our matrix. Actually, it should not be like this, but because we are just making this program to ask the user for original matrix and print the matrix row echelon and reduce row echelon form, so it makes no difference because reduce row echelon also do all the same operations as row echelon. It just added some other operations also. So at here, our program simply ends. This is our window for program. I can show it also running here. Let's say I enter the number of rows as 3, number of columns as 3. For first, and let's say I try to enter our wrong value, AC. Then it says invalid input, please enter our number. Then I enter 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is its row echelon form, and this is its reduced row echelon form. As we can see, this is fully right because this is the pivot element in row 1. Below its all entries are 0. Pivot element in row 2 is on the right hand side of row 1, and below its all entries are 0, and the same again, and same here also. Now here is the thing which I want to explain also, that why we actually make use of vector double. And also here when we try to divide by anything or which is we use here multi and multi, we also created double, and then we use div we also make it double. The reason being is if we make use of any other value, like in this function I have explained it. Let's say I use standard cout and 3 divided by 2. I'm only going to print it, so for currently I'm going to use this type standard cout. Then we see both of these values are integer and our output gets 1, but it should be 1.5. Then what is the problem? Because both of these are integer, so integer only prints the integer part and removes the fractional part, which gives error. and we don't want it at all in our program that our function give error. Wait, sorry. Now here is the other part, that why we don't use a floating number in our program. So in float there is a error. Like I have shown here, we use two double number, double 0.1 plus 0.1 plus 0.1 up to 10. And then we use this double d to 100 minus 99.0. And these are floating number. They should also equate to 1. This should also equate to 1. And our this print should print that d1 is equals to d2. But when we run this program, we see that it prints d1 less than d2. So what is the error here? It is because in floating numbers, if we enter float number is equals to 0, then it don't store it as 0, but something like 0.00001, something like this. So we don't make use of this because in our program we sometimes make use of this if div not is equals to 0, and it can give errors here because in floating that is not purely equals to 0, it is nearly equals to 0. So we don't make use of float or integer, and we make use of double number to do all of this. So I can show here now in my PPTs. This is full of our program as I have explained earlier. This is class, this is private things, this is safe input, constructor, and then our input function, void input, and here we ask for all of the input. This is our print matrix, this is our row echelon form, this is full of the algorithm. This is to reduce row echelon form of the algorithm. Here starts our main function, and this is the whole of our program. Also, I have attached the example running of this program here, like a and this 2 minus 1 minus 4, all of this, and it first prints the original matrix, then its row echelon form, and at the end it's reduced row echelon form. So this is it. Thank you for watching my presentation.